All right, instead of me going over, just asking who has a question, I'm going to try to hit a little bit of everything here. All right, so we hit basically the whole practice test. We won't do every single problem because there's some repeats. We don't have to do every single one, but we will do a few of these. For instance, number one. Let's take a look at that. It says find the sum of the measures of the interior angles. What does that mean if it says find the sum of the measures of the interior angles? What does that mean? All the angles, what? Added all together, okay? It means all the angles added up together. Well, we have a little formula for that. What's the little formula? We talked about this when I read off n minus 2, right, times 180. Right? N minus 2 times 180. And so what does the n represent? The number of sides, right? Look at number 1. They say it's a hexagon. Well, you have to know those words. You have to know what a hexagon is. How many sides does a hexagon have? 6, right? That's 6 sides. All right, so you have to know that. All right, it doesn't tell you. Now, number 2, it tells you a 16gon. That means there's 16 sides. Well, I could give you a word, and it says hexagon, and it's got 6 sides. So you plug it into the formula. Look how easy it is. 6 minus 2, and then multiply that by 180. And then 6 minus 2 is 4 times 180. I would just put it into a calculator if I were you, so you don't make any mistakes, and that would be 720 degrees. And what does that mean? That means all the angles add up to be 720. Does that mean every single angle inside of there is 720? No, it means all the angles all together, all right, added up. The sum of the interior angles is 720. That's pretty straightforward, don't you think? Yep. If they told you 16 sides, like number 2 does, what would you do? We won't do the whole thing, but what would you do? You go 16 what? Minus, come on, talk to me now. Wake up. 16 what? Minus 2 times 180, right? So it'd just be 14 times 180, plug it into a calculator, and you get that answer, all right? All right, let's move down to, we'll move down to this one right here. We'll talk about an isosceles trapezoid. This is all just review for you, all right? So it gets in your head, and hopefully you'll remember some of this stuff that we go over. Try to make this look as isosceles as I can. It's pretty close. It's not perfect. This should probably be tilted in a little bit more, don't you think? Maybe a little bit more like that, do you think? Is that right? That looks weird. I don't know, that's bugging me, sorry. I know you don't really care. But I'm gonna do like this, so then I'll know it's exactly. So let's reflect about the vertical. Alright, now, there we go, that looks better. Sorry, that just bothers me a little bit if it's not right. Okay. And they put some diagonals in here. So they go here and here. And let's put some letters in here. A, B, C, D. A, B, C, D. Alright, and they tell you which angle is congruent to angle C. Well, here's angle C right there. Which one is the same as angle C? If this is a isosceles trapezoid, it's isosceles trapezoid. Remember this? These are your parallel sides right here. These are your bases, and the base angles are equal. Remember me saying that when I read off the answers? What does that mean, the base angles are equal? It means the angles formed with the parallel sides, right? Those two are equal to each other, and guess what else is equal? A and what else? On B, right? It's not hard. Everybody see that? And that's all they ask you. What's equal to angle C? Well, angle D is. That's it. What side is parallel to AB? That's easy. This is almost baby stuff, isn't it? Okay, they're just trying to get you to understand what's true about an isosceles trapezoid. So what's parallel to AB? It's basically just given to you. What is it? DC, right? So DC is parallel. And then it says which segment is congruent to AC? Well, where's AC? A starts right here. C is down here. These are diagonals, right? So what's true about the diagonals of an isosceles trapezoid? What are they? What do they look like? They're equal to each other, right? So what's equal to AC? BD, right, or DV. It doesn't matter what order you put that in. That's all they want you to say right there. Now, 7 through 10 is a little bit trickier. It's kind of like the first one we did. but you have to think a little bit more. This time, look what they tell you. It says the measure of the interior angles of a regular polygon is given. All right, the measure of the interior angles. Now, they don't say the word sum, but that's what they're referring to. The measure of all, when they say the interior angles, plural, it means all of them added up. Okay, the measure of the interior angles of a regular polygon are given. All right, and so let's just do number 7, I'm sorry. Number 7 is 900 degrees. The question says, find the number of sides in the polygon. Find the number of sides. Now let's think about this a little bit. The number of sides. Okay, so what are they telling you? What is that 900 degrees? Is that each angle inside of our polygon? No, obviously not. Okay, 900 would be ridiculous. For one angle to be 900 degrees, right? It can only go around 360, right? So there's no way it's 900, great? So that means all of the angles inside this polygon add up to be 90 degrees. You want to find out, okay, how many sides does this thing have? If the sum of all the angles is 900 degrees, how many sides does it have? Well, we actually have a formula for this. And we just a few minutes ago talked about this formula, didn't we? And what was the formula for the interior angles, the sum of the interior angles of a polygon? N minus 2 times 180, right? What does that number give you? It gives you the sum of all the angles inside of that polygon. Do I know the sum of the angles inside this particular polygon? Yeah, what is it? It's 900, exactly right. So look, this thing right here is equal to 900 degrees. Make sense? This right here is the sum of all the angles, and they tell us the sum of all the angles. They tell us it's 900 degrees. What are we looking for? The number of what? So what are we solving for here? N. That's right. We just solve for n. Let me show you how to do the algebra. Okay? If I want to get n by itself, what are we going to get rid of first? The 180. The 180. Get rid of the thing that's being multiplied first, and then we'll get rid of this thing right here. Okay? So get rid of this 180. So we divide by 180 here, and we divide by 180 there. Everybody see that? So what are we left with? N minus 2 equals, and this cancels out, 900 divided by 8, or 180, I think it's 5. All right? Now it's real simple. What do we do to get n by itself? Added 2. All right? So we just use this formula right there that we used earlier, but we're solving for something different. This time they don't tell us the number of sides. We had to find the number of sides. Okay? And then n is what? 7. So how many sides does this polygon have? It's got 7 sides. All the angles would be 900 degrees. Make sense? So 8, 9, and 10 are exactly the same thing. So basically, what did we end up doing? We just did what? Divided by, and yeah, we reversed it. Okay, we divided by 180, and then we added a 2. Okay, that's kind of reverse of what we did in the first two problems, right? Instead of subtracting 2 and multiplying by 180, they did what? Divided by 180 and added a 2. See that? Know the formula, though. This right here was really important. Okay? You had to set it up like this, and then you could do the math. The math isn't that hard. Do it a few times. If you didn't understand, if you didn't quite get this, 8, 9, and 10 are there right for you to do, okay? And do those 2 or 3 times, and you should be able to remember how to do this. So if I give you something like this on the test, you should know how to do that. All right? So 8, 9, and 10, that's up to you. You can do that on your own. All right, let's take a look at number 11. Almost even hate doing number 11 because it's pretty easy, but let's do it anyway. We've got time. Let's make this look like a parallelogram. And let's draw some diagonals inside of this. Alright, and this is what they tell us. Let's try a different color here. They tell us this line segment right here is 14x minus 34. And they tell us this one right here is 12x minus 8. 12x minus 8. Alright? And they ask you to just solve for x. That's all they ask you to do. It's just find what x is equal to. Well, this couldn't be easier. This is a parallelogram. They tell us it's a parallelogram. What do we know about the diagonals of a parallelogram? What do they do to each other? They bisect each other. That's right. They split each other in half. So what do you think is true about this segment right here, from here to here, and this one from here to here? What are they? They're equal to each other. That's right. So what do? We set them equal. We'll just do the math just to refresh you a little bit. Set this equal to this. Now, I actually put the 14x first. Why do you think I did that?
You don't have to deal with the negative.
Yeah, you don't have to deal with the negative and plus. I got it on the left-hand side. It seems like we always like to solve for x on the left-hand side, don't we? That's how you learn in Algebra 1. So that way, watch, I can just subtract a 12x from both sides. Now watch this. I could bring everything else down, but let's get rid of the 34, right? I move the x to the left. Let's get rid of this minus 34, and we get rid of it by adding a 34. And then this is plus 34. All right, so that cancels and that cancels. That's 2x, and that's what, 26? Is that right? Yep. And then divide by 2. X is what? 13. All right. Now, it might not be that easy on the test. They could ask you, what do you think they might ask you? They might ask you to solve for, like, AC. What would you have to do if I asked you to solve for the length of AC? Plug it in. That's right. Take that 13, plug it in, right? Work it out and see what you get there. Make sense? I could ask for AB, right? Well, what do? Plug it in here, get this number, and then just add it to the same thing, right? And then you got the whole thing AB. So there's a lot of varieties of things that I could ask you on a problem like that. It's pretty simple. Just set them equal to each other. How many times have we done that this year? Set things equal to each other, solve for x, plug it back in. We've done that a ton, haven't we? I mean, almost this whole geometry class boils down to doing that. Taking things, segments, angles, whatever it is, setting them equal to each other, solving for x, and then plugging it back into something, right? Or in that case, just solving for x and you're done. All right? About halfway through. That was quick, wasn't it? Let's do another kind. Let's go up to the top of page 449, number 12. What does that thing look like? A kite. And they actually tell you. It doesn't just look like a kite, it is a kite, because they tell you it is. Let's make it kind of look like a kite. There's that. There's that. And there. Alright. And they tell you that this is 3 and this is 4, and they're asking for GF. GF is this one right here. We'll just call it X, is that right? Instead of calling it GF. Now, this is a kite. They told us it's a kite. We got to know something in order to solve for X, though. We talked about this a couple times yesterday. These are what? Say it, Brian. They're perpendicular, right? Which means that this is a right angle, which, John, means you can use what now? Pythagorean Theorem. That's right. If you have a right triangle, and you do, this is a right triangle right here, isn't it? You can use Pythagorean Theorem. I'll just shade it in so you can see which triangle I'm talking about. That one right there. Everybody see that? So now you can use Pythagorean Theorem. How do we use it? A squared plus b squared equals c squared. So which one of these is the c? The x, because it's the what? The hypotenuse, right. It's across from the right angle, which makes it the hypotenuse, exactly right. So the c is this x right here. So I'm going to go 3 squared plus 4 squared equals what? X squared. Let's do this. This is 9, that's 16, and that's x squared. Add them up. It's 25 equals x squared, but that's not my answer, 25, is it? What do I have to do to this x squared? Square root it, right, to get rid of the squared. And what's the square root of 25? It's just plain old 5. So x is equal to 5. We're going to do a chapter in a little while, chapter 8, 2 chapters from now. Actually, 1 chapter in between, however you want to say it. It's called a 3, 4, 5 triangle. Right? See how they come out to nice, even numbers right here? Not all right triangles come out where all 3 of these sides come out to nice whole numbers. Okay, there are some special triangles that do. And this is one of them. It's called a 3, 4, 5 triangle. It's very, very helpful. I mean, when I looked at this, it's not because I'm really smart or anything, but it's because I recognize I got a 3 and I got a 4. What's the hypotenuse going to be? It's going to be 5. So if you recognize this on a test or something, you wouldn't have to go through all this mess right here. You could just recognize, oh yeah, one leg is 3, the other leg is 4, the hypotenuse has got to be 5. Does that make sense? What if this was 6, and what if this was 8? What do you think the hypotenuse is going to be? It's going to be 10, right, without doing any Pythagorean theorem at all. It's kind of handy, isn't it? Yeah, and it will come in handy. When you take the SATs, I almost guarantee you'll have at least one problem where they're going to put one of these special triangles on here, and if you recognize it's 3, 4, 5, it'll save you a lot of time and a lot of effort instead of having to go through this. I mean, it's not hard to do this, but it's nice recognizing 3, 4, 5. All right, just thought I'd throw that out there since it showed up. All right, let's do another kind, and we've done a couple of these problems already. But I want to review it again. That's what review's all about, right? Do stuff that we've already done, but just to remind you. So I'm going to try to make this look like a kite as much as I can. It's pretty close. And they tell you that this side and this side are equal, and this one are equal. That makes that a kite right there, doesn't it? Having those two, these two equal and these two equal, yeah. And they tell you this angle is 67 degrees, and this angle over here is 49 degrees. And they ask to find this angle down here at the bottom. All right? Well, let's review a little bit. Do we remember anything about a kite and these angles? These two angles are given. What's true about this angle down here and this angle up top here? They're equal to each other, so that's very, very helpful. If we didn't know that, we really wouldn't be able to solve for either one of those, okay? But we do know that they are equal to each other, and that's really helpful. So what's the process? What do we do? Somebody want to volunteer? Okay, let's add 67 and 49. Let's see what we get for that. Let's add a 6, and that's a 116. Okay, so these two add up to 116. Does that mean this angle is 116? No. By 180? 360. Why 360? Right, because it's quadrilateral. There's 4 angles, and all 4 of these angles add up to 360, don't they? So what I'm going to do is I'm going to take 360, subtract 116, subtract these two from it, right? And let's see what I get. That'll be a 4, that's a 4, and that'll be a what, 2? Does that mean this angle right here is 244? No, it means the two added together are 244, but they're both exactly the same. So what can I do? Divide it by 2, right? So let's showing all my work, right? So that's what? 122. And that's what that angle is right there, 122 degrees. And of course this one down here is going to be what? Same exact thing, 122. All right? Remember this problem? We've done this a couple times, haven't we, in the last day or two? Yep. So make sure you do that. Make sure you take it away from 360, not 180. All right? I was teaching this in 3rd period, and I said 360, and I'm like, okay, make sure you take it from 360, and guess what I did? I took it away from 180, okay? So even I can make a mistake on this, all right? It's not that hard to mess up because you're so used to 180 all the time, you're not really used to 360, but you got to remember all 4 angles add up to 360. We got it? All right, cool. Let's move on. This stuff seems so easy now, doesn't it? Right? It's a lot of information. It really is. It's a whole lot of information you got to keep straight. But once you keep the information straight, the math and solving for what they ask you to solve for is really not that hard. I don't think. Do you? Yes? No? Maybe? No. Okay. Good. Thanks. Somebody's alive. Let's grab this thing right here. And let's scroll down. So we have some space here. Wow, I've done a lot already. What do you think this thing is? It's a rhombus, right? What's true about a rhombus? I mean, a lot of things are true, but by definition, what is a rhombus? It's a quadrilateral with what? Yeah, they're parallel, but any parallelogram has... But what's specific is true about a rhombus? All the 4 sides are equal to each other, okay? So on a rhombus, all 4 sides are equal to each other. It is a parallelogram, so all the stuff that's true about a parallelogram is true about this. But specifically, all the 4 sides are equal to each other. All right? Let's throw a couple diagonals in here. Right there and right there. And let's see what they're going to ask you. All right? Let's put some letters in here too, since this is M, N, O, P, and R. Okay? So the first question, I'm looking at number 14. Okay, it says MRN. No work involved. MRN. Angle MRN. It's this angle right here. What do I know about it? I wasn't given any numbers or anything. How in the world could I find that angle if I'm not even given any numbers to work with?
90.
It's 90 degrees or perpendicular. Remember, the diagonals of a rhombus are perpendicular to each other, so that makes a 90-degree angle. Again, there's a lot of stuff to remember about diagonals, and if they're perpendicular, if they're not, if they're equal, or they bisect each other. There's a ton of stuff to remember, but once you remember it and realize, then it's not that hard. So that angle right there is 90 degrees. That's all they ask for. Easy. That's 14. Look at 15. This is just as easy. It says if PR is 12, let's go a different color here. So PR is 12. What is RN? Well, that's easy too. At least the math is easy, but you got to understand. Watch, if this is 12, what is RN? That's 12 as well. Why is it 12? How do I know that's 12? Because they bisect each other, exactly right. The diagonals of a parallelogram bisect each other. Everybody got that? All right, so that's 12, that's 12. What if they asked for PN? What if they said find PN? It's 24, right. Everybody see that? It's not hard. Find this one, the whole thing is 24. Piece of cake. Good. Let's do one more. Angle PON, let's find that. A lot of people have a hard time understanding what angle I'm talking about. So let's do this. We start at P, we go to O, and we go up to N. So it's this whole big angle right here. Everybody see that big angle? So they tell you that angle right there is 124 degrees. So that big angle is 124 degrees, that big blue angle. I'm going to go a different color here. And they ask you to find angle POM. So where's POM? It's this one right here. It's this little skinny one right here. Everybody see that? So what do we know about the diagonals? What do they do to the opposite angles when you have a rhombus, right? They bisect the angles. That's right. Now do they do that for every parallelogram? No, only when it's a what? A rhombus. Good. So this angle right here, it's being bisected, isn't it? This big angle is being bisected. So what's true about this angle and this angle right here? They're equal. So if the whole thing's 124, how do I figure out this little yellow one? Divide it by 2. So if I divide that by 2, it's what? 62 degrees. Everybody got it? Pretty simple. Again, the math hasn't been hard at all, has it? The math has been very easy. It's understanding what these lines are doing to these figures. Do they bisect it, or do they make it 90 degrees, or do they do what? What do they do to it? That's what you have to study. That's what you have to know. And there is a lot of information. I'm not lying to you. You know that, right? There is a lot of information that you have to know here. All right. Let's do another one, kind of like this. It's pretty easy. And I'm not even going to put a diagonal on this one. I'm going to say that this is 109. Actually, let's go this one. This is 109 degrees, and I'm asking you to find this angle right there. And this thing is it just says it's a parallelogram, okay? It's not necessarily a rhombus. It's just a parallelogram. All right? So if this is 109 degrees, what do I do here? Now look, you guys just took a quiz, and I passed it back to you, yesterday, I think. A lot of you guys did this. A lot of you guys took this angle up here and set it equal to this angle down here. Are they equal to each other? Now look at it. What kind of angle is that right there? It's obtuse. What kind of angle is this one down here? It's acute. Is there any way that they're going to equal each other? No, there's not. But still, I had several people, not just one. I mean, I had several people set this and this equal to each other. Do you remember that one on the quiz?
Yeah.
It was like, was it the last one or the next to last one? It was one of those, okay? Was it the last one? Yep, where you had to not set them equal to each other, but what did you have to do to them? Somebody said it earlier. They're supplementary, that's right. And if they're supplementary, what does that mean they are to each other? They add up to 180. So I take 109 away from that, and what do I get? 71? Is that right? So that would be 71 degrees right there. Again, the math isn't hard, but you got to know the relationship between those things. You can't set them equal to each other. Got it? All right. And this is really super easy. If that's 6 right there and this is a parallelogram, what is this? We'll call it AB. What is AB if this is 6 down here? That's 6. That's a piece of cake. Okay? You good with that? All right. Let's do one more little section here and we'll be finished. How about that? What's this thing look like?
Rectangle.
Rectangle, exactly. And let's put some diagonals in here, and we'll label it. Now this algebra is a little bit more involved than the algebra we've been doing so far, because I keep saying the algebra is really easy, the math has been really easy. This is where you might have struggled a little bit, probably not with the geometry, but with the algebra. And let's see what they tell us. They tell us df. They kind of tell us df. Now look how they write this. They don't usually write it like this, do they? Look, that's what df is equal to. Usually it's just like x plus 5 or 3x minus 1 or something like that, right? But they write it like this time. And they also tell you eg. eg. And they write it like this. And they ask you to solve for eg. This is what you want to solve for. You want to find out, not just solve for x, but you want to find what eg is equal to, the measurement of eg. Well, let's take a look at df and eg. Is there anything true about the two of them? Here's df, this one right here. That's a diagonal, isn't it?
Yeah.
And look at eg. That's a diagonal. What's true about your diagonals of a rectangle, Anthony? They're equal to each other. Okay? They're equal to each other when it's a rectangle. Are they equal to each other when it's rhombus? No. Are they equal to each other when it's just a regular parallelogram? No. They're only equal to each other when it's a what? Rectangle. What if it was a square? Would they be equal to each other?
Well, I guess yes.
You guess what? Just because I paused? Let's think of why. Why are the diagonals equal to each other on a square? Because a square is what? A rectangle. That's right. A square is a rectangle, isn't it? Because a square is a four-sided figure with 4 right angles. Would you agree? Isn't that what a rectangle is? Yeah. So a square is a rectangle. So the diagonals would also be equal to each other on a square. Got it? All right. That's the only time, though. Square and rectangle. Got it? Good. So they are equal to each other. So what do we do here? We just set them equal to each other. So let's do the math. So the geometry was easy. The geometry was just saying, okay, they're equal to each other. All right. Now it's all math. It's all algebra. I'm going to just rewrite it again with an equal sign in between it. I'm going to go through it kind of quick here, so follow along. I am recording this, so you can always go back and look. First thing I'm going to do is distribute the 2. So that's 2x plus 10, and then you stick that minus 7 right there. And distribute the 3. So that's 3x minus 6. It's not like we haven't done this kind of stuff before, but, you know, I'm going to go do it anyway. So what do we do here? Add like terms. Positive 10 minus 7. That's a plus 3. Write this down if you weren't sure about this. And we want to solve for x. Let's get x on the same side. Now you could subtract a 3x, but I would rather subtract a 2x just so that I get a positive x. I think it's a little nicer. And then go ahead and add a 6 to both sides. Everybody see that? Put the x on the right-hand side, put the regular number on the left-hand side. And we always did the opposite every time. Look, that canceled out right there. That canceled out here. That's 9. 3x minus 2x is 1x, so x equals 9. Do I circle that as my answer, though? No, because what are they asking? They're asking for EG, aren't they? All right, so you just take that 9 and plug it in for x. So it's 3 times 9 minus 2. And that's 3 times 7, and that's 21. That's how you do it. It's not so bad, is it? Did that stuff really make it any difficult? Did it make it difficult? No, I don't think so. I mean, maybe a couple extra steps than you're used to doing, but I think I was pretty basic. That's pretty much it. We covered just about all of this, didn't we? All right. So there's your review. We'll do another review on Monday, though, okay, because I'm going to give you a worksheet tonight, and you'll do that worksheet on Monday. So I'm going to let you hang on to this, all right? Hang on to this homework. Why do I let you hang on to these homeworks and don't collect them right away? So you can use them to study from, okay? That's what you're supposed to be doing with them, all right? Don't just put them away somewhere and just say, okay, I got to remember to bring it on Tuesday, the day of the test. Make sure that you use them to study from, all right? And the same thing with the worksheet I'm going to give you tonight. I'll let you hang on to that until Tuesday. Why until Tuesday? What's happening Tuesday? Test on Tuesday. Test on Tuesday. All right, and it's chapter 6. All right, that's it.